cancel. This 1x right here cancels out one of those. And now we write whatever is left over. So on top, the only thing that is left is x. And in the denominator, that x is gone. That's gone. And we have 3 times x minus 4. Yeah.
So you don't like run that through with that?
No, it's not necessary. You could, I wouldn't count it wrong, but it's a waste of time. Side note, x over x plus 2. I want your full attention. You ready, Robbie? You listening? Everybody's listening? I need your full attention. Those x's don't cancel. Ever. No matter how hard you try, no matter how many times you cancel those out, it will always be wrong. You cannot cancel these. You cannot cancel parts of addition. Look, you can cancel the entire addition because we're really canceling a part of multiplication. That's not a problem. Now, if you're like, well, why can't you? 4 over 4 plus 1 is 4/5. That's it. That's the answer. It's 4/5. It's nothing else, right? You can't cancel these and say it's 1 over 1, it's 1. It's not. It's 4/5. You cannot cancel parts of addition or parts of subtraction. And I get calculus students that try that. It's like, I see that mistake all the time. Robbie, you can't cancel parts of addition, all right? Got me? All right. You're just the closest. That's just it, all right? Okay, all right. X plus 4 over, this is x plus 4. Well, I guess I use the same one. How foreshadowing was that? So I can factor the denominator, and you can cancel all of addition, because you're really canceling a part of multiplication. That's legal in Nebraska. There we go. So 1 over x minus 4. If everything goes away, it's a 1, because it's division. You're dividing x plus 4 divided by x plus 4. That's 1 over 1. That's why there's a 1 up there. Okay, so now we get into a little bit more involved factoring, but it's the same stuff. Factors of 16 that add to 8, x minus 4, x minus 4. There's factors of 16 that add to 8. And then we have x plus 8. Oh, no, wait, not 8. 6 and 4. Not 8, sorry. X minus 4, x plus 6. So this is more about factoring than actually canceling. But then you got to cancel in the end. All of that cancels with all of that, and those don't cancel. The x's don't cancel. They don't. You can't cancel parts of addition or parts of subtraction. So we have x minus 4 over x plus 6. Over here, the only thing I see is factor out a 2. X squared plus 5 doesn't factor. X squared minus 5 wouldn't factor either. So we're done with that one. 3x and x. And somehow I need a 16. Well, 3 times 5 is 15. So I'll put the 5 over there. I'll put a 1 there. Nothing cancels. So it's prime. It's a prime number, essentially. Well, it's a fraction that doesn't reduce. So we factored it. We looked at what is the same. X squared plus 5 and x plus 5 are not the same. They're very different. And so that's it. That's it on that one. Yeah. Oh, it did switch, didn't it? It just switched really late. Multiply rational expressions. Remember to simplify first. All right, we'll simplify first. What can we do? I can cancel this one with one of these. That's a possibility. I can cancel all of these with 3 of those. How about all of these with 4 of those, leaving 1? How about 5/15 is 1/3. 27 divided by 3 is 9. Follow me? It doesn't matter that they're across from each other. It matters what's on top and what's on the bottom. That's all that matters when you're multiplying. And then 9 divided by 3 is 3. So I see a little bonus canceling on that one. Now I gotta remember, now this is a mess. I gotta find out what's left. A 3 is left on top. Here's an x. 1x is over here, so x squared. Over, there's a y here and a y there, so y squared. That's what I get for a final answer on that, after all the canceling. It doesn't matter if they're literally above or below each other. It just, if they're on top and one's on the bottom, you can cancel. It doesn't matter where they are. All right, how about this one? Take out a 5x. 4 minus x, right? Take out a 5x. Down here I can take out an x. Now remember, we're dividing out. X divided by x is 1. So that becomes x minus 1. X plus 4, x minus 1, that's how that factors. And x plus 4, x minus 4. I think I have everything factored as much as possible. Now, we're just looking for what's on top and what's on the bottom. It doesn't matter if they're across from each other. This x minus 1 cancels out with this x minus 1. This x plus 4 cancels out with this x plus 4. The x's cancel. This is an x to the first, this is an x to the first. Those are gone. What we're left with is 5 times 4 minus x over x minus 4. Let's investigate that very carefully. If I have 4 minus x, right there, you see that 4 minus x on top? I want to you can factor out anything you want. You can factor out a 10 out of that if you want. You just have to work with fractions. I can factor a -1 out of this. So what's 4 divided by -1? -4, right? What's negative x divided by -1? Positive x, right? I can do that, because if I distribute that -1 back through, I get exactly what I started with. So that's fine. Well, now I can turn these around. If I turn these around, they have the same sign. I got to keep the same sign, right? So I can make it as x minus 4. You can turn subtraction around as long as you make it negative. Now, what does that mean for us? If I make this negative, -5, then I can turn this around. Those cancel, and I'm left with -5. Now that only works with subtraction. So you can have 5 minus x, you can make it negative x minus 5, and you need to do that. If you leave it like that, I will not give you full credit. There's another step you can do. You make it negative and you can cancel it when they're minus and they're backwards. This is x minus 3, x plus 3. This is x minus 4, x plus, I probably should have done it in a different color. X minus 3, x plus 2. So that's what ooh, there's a chair back here, a stool. That's what I get when I factor everything. Now we start canceling whatever we can. Gone, gone. That's gone, that's gone. I think that's it. X, oh, did I miss something?
So it has to be a -6 for it to be -3.
Oh, yeah. So that does, oh, thank you, Robbie. You're better at this than I am. Let's redo. Doesn't change this. Thank you. So that does not factor, right? Because it'd only be 6 and 1, that'd be 7, 3, and that'd be 5. So this one does not factor. That one does not. So now, this cancels with this. And that's all you have, right? Over x, well, we can, this, there's a choice. You can either leave it as x minus 3, x plus 3, x plus 4, or as it turned out, nothing canceled out of this. So you could also write it like that. I would count either. If you just leave it in the factored form, I'm okay with that. What do we do when we divide by a fraction? Multiply by the reciprocal. All right, so we multiply by the reciprocal on this one. Because it's the division sign in between. 18xy to the third over 7a squared b squared times 35a squared b over 12x squared y. Multiply by the reciprocal. Now we start canceling whatever we can. 35 divided by 7 is 5. 6 goes into 18 and 12. That's a 3. That's a 2. So 18 twelfths reduces to 3 halves. The a squareds are completely gone now. This 1b cancels out one of those, leaving 1. So that's so far. Now I need to deal with the x's and the y's, right? One little piece at a time. This 1x right here cancels out one of those, leaving 1. And finally, this y right here cancels out one of those, leaving, but it leaves 2 of them. Now that's half the battle. The rest of the battle is actually looking in that mess and seeing what's left. So 3 times 5 is 15. I have a y squared left here, and all of that went away. So on top, it looks to me like I just have 15y squared. And then help me out here. I have 2bx. That's what I think, because that a squared went away. Questions on that one? Multiply by the reciprocal, then start canceling, reducing, dividing, all that good stuff. Divide rational expressions for find any restrictions on the variable. All right, so I want to factor this one, x minus 7, x plus 3, factor this. I can take a 5 out, so there's the first one factored. But we're dividing, so I need to multiply by the reciprocal. This x squared minus 100 is x plus 10, x minus 10, but now it's going to be flipped up to the top. X plus 10, x minus 10, 7 and 10. Now this top one goes down to the bottom, x plus 10, x minus 7. X plus 3's cancel, x minus 7's cancel, x plus 10's cancel. So we have x minus 10 over 5. But x cannot equal, do you go back to the original? I'll get back to you on that. Go back to the original. I'll get back to you on that one. I want to see how the book is managing their restrictions. All right, so let's move on. I'll come back to this. This one we have 4x over 5 times x minus 4. Times is going to be x minus 4, x minus 2, but that's this one right here. That's that one. That goes to the top now because we're multiplying by the reciprocal. Over, I can take an x out of here, x minus 2. We got it all factored. We multiply by the reciprocal. We're going to start canceling. X minus 4 is on the top and bottom. X minus 2 on the top and the bottom. Even the x's cancel. So we're left with, I think, five, not 5/4, but 4/5. 4/5. I'll get back to you on those restrictions and see how the book is handling those. Is that it? That's it. All right, I got some looking up to do. Your assignment is, what do we got? Is it just a worksheet after it? Okay. Simplifying expressions worksheet. Perfect.